Very good evening, everybody. Welcome back. Welcome back, all our regulars, friends who have been supporting us for all these time. And as committed, we shall continue to. Everybody, welcome back. Welcome back, all our regular. As committed, we shall continue our efforts towards giving you a lot of insights with reference to the interview questions, how to answer them, etc. So people who are joining afresh, I had made a request in the last two sessions for our regulars to invite their friends, family, etc., who could stand to benefit from this. I'm assuming that many of you would be joining. So many of you joining afresh, you can please go back to this particular channel and watch the old recordings of this series, where we have a discussion among the experts with reference to the various topics. And we've already discussed that we'll be going for a deep dive into each of these topics starting next week. So in continuation at a high level, the topic that we are planned for today is monitoring and maintenance, but something we have missed out in the last session, and that was with reference to the evaluation, all right, or the success criteria, or how do we define that, or how do we know we have achieved what we have set out to achieve. You have the business problem, based on the business problem, based on the data, based on that we did EDA. After the EDA and all that pre-processing, we decided to do the model building. We built the model. For model building, we did partitioning, and then we checked everything. We got something. Now, what we have got finally after the entire process is done is actually what we had set out or started to discuss. How do we match the two? How do we map the two? How do we check for the two? So that is also an important aspect. So I'd request today, I'll change the order. I request Barney to please throw some light on what are the strategies one uses for this.
Yeah, sure, Nitin. Thank you so much for asking that question. In CRISP MLQ framework, we have a phase called as evaluation. And most often than not, people mistake it to model evaluation. It's not model evaluation phase, it's evaluation phase. And within evaluation phase, you don't just look at whether your machine learning algorithm is giving you the desired accuracy or not. Is it giving you the prediction results in the desired stipulated time or not? That's probably within 0.1 second, I want the prediction to happen on the new data, so on and so forth. It's not just about the model evaluation aspects. It's about the success criteria that we have defined in phase one. In the initial phase, we would have defined the success criteria, right? And it's not just machine learning success criteria. We would have defined business success criteria, economic success criteria, and machine learning success criteria. So we are trying to solve a business problem. And in the due course, we happen to use machine learning. And because of that implementation, we would save some money for the customer or for whomever you're doing a project. Given this, in the evaluation phase, one has to look at what is it that we have agreed upon, what was the success criteria that we have defined, and what is the success criteria that we have achieved. And at the very beginning, the success criteria that we set out, usually you give a range that I'm going to save anywhere between $1 million to $1.5 million in that way. At the very beginning, at the beginning of your project, when you define, a lot of things might not be clear. So as an industry standard, even if there is plus minus 50% variation, it is acceptable. That's according to PMI, Project Management Institute, best practices norms. That is what PMBOK guide, Project Management Body of Knowledge, says. That plus minus 50% variation is acceptable. But as in how you approach the evaluation phase, that broad range that we have defined has to come down, as in how your understanding improves. And then you should narrow it down, saying that anywhere between 1.2 million to $1.3 million is what I'm going to save. Against this narrowed down success criteria, which has been refined, you're going to evaluate and see whether you're meeting those success criteria norms defined or not. So that should be the critical thought process when it comes to evaluation phase. Yeah, over to you, Nitin.
Sorry. Yeah. Thank you. Thank you, Bernie. I was fumbling with the buttons there. My bad. So thank you for that. Yeah, that definitely brings a lot of clarity. So I'd like to, for the benefit of the audience, sum it up. The key. I'm sure many of you have flown, and if you have not, you must have at least read about those air pockets which causes disturbance. So the big air pockets in our data science journey is first with the data. Once you have navigated that, you have the issue of pre-processing whatever is there. That is another aspect that you need to look at. The smooth ride, real smooth ride, and where the pilots can simply relax, is basically the model building. After the model building has been done, the another small air pocket is with reference to after the entire thing. You realize, are we in line with what we had set out to do? All right. Or can we really say QED, or we have simply digressed into something else altogether? That is where we bring in the success criteria. That is another air pocket that we need to navigate. The biggest air pocket, I feel personally, is something that when the data scientist begins to relax, finally given it to the client, now let him take over, it is his job. Then after about 15, 20 days, knock, knock, knock. Mr. Mishra, Mr. Sharath, Mr. Barney, what is this? Oh my God. So don't worry. I'll help you. So monitoring and maintenance, that is the operative word. So, and you really cannot be prepared for surprises that come. We try at our best level, to ensure that these kind of issues we monitor, and we ensure that in production level environment, nothing like that happens. But we should be prepared, and what are the things we can do to prepare for that is the crux of the discussion that we're going to do today. And my question to Sharath is, what are all the steps? Again, like I said, what will happen in the real production, we cannot foresee. Some entirely new things can happen, right? Version problems, environment, software, people using it, whole lot of things beyond our control is there. But what is it that we do as part of monitoring and maintenance, all right, to ensure that we have as minimum downtime as possible with our application running in the client side? Could you please elaborate on that?
Yeah, thank you, Nitin, for that question. It becomes one of the important questions in nowadays, the current trending scenarios. As you mentioned, downtime. That's a very key, important word, and I want to revolve my answer around that particular word. Whenever we talk about any machine learning solution that we are giving, you have to look at that as a service. Ultimately, you're giving some solution to your customer, and the customer is trying to use that solution. So it's a service. Now, over a period of time, the service should continue behaving as it was behaving when we hand it over to the customer. Now, there will be multiple aspects which can impact the performance of that particular service. For example, customers' business might have grown, right? Now, when you say customer business has grown, the number of footfalls that are visiting to that particular service, let's say we have 10 people using the service when the service was deployed. But probably over a period of time, we might have 100 people or maybe 1,000 people. Is the application as a service capable to support all those requests? Now, when I talk about this, we are looking at hardware capabilities, including network and all those things, right? The Retraining would be another aspect, because as the business is growing, new data is coming up. And if you remember, I've already spoken about the data drift. Right? Briefly, I was touching upon the data drift. As I mentioned, today the business is running with 10 end users, for example. Suddenly the business grows and maybe they now have 100 users. So you can see the volume of the data is growing, and the data will also move slowly, but steadily it will move. So what are the differences that we are looking at? Because of this data drift, your performance in the model will also change. So likewise, we will have multiple aspects which impact the performance of the application that we are developing, right? Simply look at this as a service, software service. So from that perspective, we'll have to start thinking. We'll have to prepare a checklist. As we discussed earlier, ML ops standards are something that we'll also have to consider. You need to talk to your deployment team. You need to talk to your operations team, hardware team, software team, right? You consider all the aspects, the 360-degree view of your software. Right from data quality, the size of the data, the integrity of the data, the characteristics of the data from an EDA perspective. When new data is coming, is there any drift? You will have to compare with that. And we have a lot of tools which are, they're wonderful, awesome tools that you can use right now. When we used to work on projects, we had to do all these things manually, but now we have tools which can very simply, right, automate the entire process. One such tool that I've recently worked on is Evidently, right, and it's very easy. Super awesome tool. You can just get the entire reports directly, and it clearly tells whether there is any deviation detected, drift detected. So we have to keep all these things continuously mapped. You need to decide on what are the cycles that you are going to revisit for your model training, retraining, I would say. It depends, again, the business requirements, the volume of the data that business is generating, the footfalls, right? Multiple aspects will come into the picture, and you'll have to define the interval. And according to that, you'll have to revisit to your model to ensure that it is retrained. Now, when you're retraining, again, there are multiple aspects. Do you want to retrain it from scratch? Do you want to do it on incremental basis, right? All these things have to be considered. And it has to be continuously validated or continuously monitored to ensure that the accuracies are continuously at the same level. And as I said, we can experiment tools like Evidently to do that.
Thank you, Sharad. Friends, the answer, while seems a little, straightforward and simple, it is about learning to, what shall I say? It is something that you will always learn it afresh. The problems that are going to be there with reference to monitoring and maintenance, whatever tools, whatever armory, whatever shielding that you are ready with, whatever things you're ready with, you never know how things are going to, come up in the other way. So every time you'll have to probably relearn the wheel and have a strategy come out. But the general framework of things, like Sharath has mentioned, is pretty much the same. So I'd like to ask Barney, with reference to his experience of having executed so many projects and many of them running successfully. So in your opinion, what do you feel is the cycle for update? All right, is there a thumb rule, or how do you, judge or decide before you give it for production level or the client side?
Okay. Thank you so much for that question, Nitin. Usually people assume that building a machine learning algorithm is one-time task. I build the model, deploy the model, job done. That's not the case. Usually your senior data scientists spend a lot of time understanding the business problem, building the model, evaluating that, and deploying. Post-deployment, the junior data scientists take up the task of monitoring the model on an ongoing basis. And Sharad has already spoken about data drift, about model drift, right? And we also have something called as concept drift, and we have a lot of other things. Data depends, the underlying data on which you have trained your model changes significantly. Maybe age as a column in my project was in between 22 to 68 years. That was a range. Eventually, this particular bank ventured into education loan. So the underlying data started having data of 12 years, 13 years, 14 years lapse. So the underlying data changed. Hence, we had to retrain the model. Okay, and if the model accuracy when you have given the model to the customer was say 92%, and over a period of time, because of whatever reasons, maybe the accuracy kept on decreasing. So usually the industry norm is 5%. If you see 5% change in the accuracy of the model, either ways, good or bad, you'll have to analyze why it is good, what changed because of which you are having better accuracy now, or what changed because of which your accuracy has reduced. You'll have to relook at it. Third aspect is you need to look at something called as PESTEL. P-E-S-T-E-L. Political. If there is any political change, for instance, when Donald Trump was US president, he has laid certain his team actually has put down certain rules saying that people who travel from certain Middle East countries or Islamic countries into US, they were not supposed to carry laptops along with them. Even in business class, it wasn't allowed. So the prediction models which were built to predict the load factor, occupancy percentage of different flights has gone haywire. The prediction models have gone haywire. They were acting weird. Why? Because that's a sudden political change and people stop traveling because they know that, we cannot carry laptops. So a lot of business users stop traveling. And the model prediction versus the reality, it wasn't matching. So whenever you have such political change, you will have to relook at your underlying data. When I say political, what bill is being passed in the parliament is also something which people have to look at. Of course, the junior data scientist or data scientist might not have a keen eye on that, but your chief data officer or chief data scientist has to keep a tab of all such things. What if there is a law introduced which says that only electric vehicles should be there, electric vehicles of so many watts should be used, so on and so forth, right? So all those things have to be incorporated into the models that we build. Economic change. There is a recession going on, across the globe to a great extent. So it's an economic change. So the buying patterns of the people will change. People who are investing money in purchasing properties might change, right? Their behaviors change. Social change. We had COVID. And because of COVID, the way we deal, the way we interact with the people, everything has changed, social distancing, so on and so forth. So there has been a change. Because of that, the kind of data which gets generated also changes. A lot of people sitting at home started ordering food, right? So a lot of people, stopped going on international vacations. So aviation industry data got changed. And whenever you have technological changes, maybe you were manually recording the data in the past. People were manually resorting to record the data. And maybe they upgraded their systems now. They have automated certain aspects and now it's digitally getting recorded. So whenever we have such technological change also, we need to take an action in terms of upgrading the model. Any environmental changes, any legal changes, right? If you have a reorg, a new person has come in, for example, as a CEO, the first thing they might want to do is relook at the processes, change processes, etc. That would change the underlying data also. So you always have to keep a tab on these aspects and figure out on when to actually upgrade the model. So if you ask me, is there a generic thumb rule as such for these kind of things? We do not. But usually with respect to the amount of data, if you have more than 20% of data, you trained on some amount of data. If you have 20% of this trained data, which is coming as a new data, then you retrain your model. Or if your accuracy is dropping by or changing by 5%, that is when you might want to intervene and take necessary action. So these are a few aspects which people have to focus upon when it comes to model upgradation, monitoring and maintenance. Yeah. Thank you, Mithun.
Thank you, Barney, for that elaborate and detailed answer, especially the insights with reference to the external factors that, Barney.
Yeah, one more thing I forgot to inform is that we actually are doing a lot of manufacturing analytics, wherein we use a lot of IoT sensors. When you use IoT sensors, there'll be a lot of wear and tear, right? Devices get damaged. There'll be a lot of fluctuation. So, and there'll be a life for each and every sensor. You install a sensor, it will work for the rest of the life, but it doesn't work that way, right? So they might get damaged, or over a period of time, they might get degraded because of excess heat or whatever. And they might start, sending wrong data to you. So you can also define a rule which says that once in every 6 months, we will, recalibrate or we will replace the sensors. And because of that, we might get new data and we'll have to retrain. Okay, so that's another thing that I wanted to add. Yeah. Over to you.
Yeah, right. That was, I myself coming from the manufacturing line. Yeah, we have policies in place where calibration data, it's generally within a year, and certain very big instruments, it is 3 years, up to even 3 years. So any recording devices in a reasonably good size company, which is going to invest in IoT sensors for process improvement, will have calibration strategies in place, and because of which certain changes data may come. And yeah, so the thing that I wanted to, while Barney was giving the detailed explanation, I was reminded of another YouTube video that I saw about some absurd studies. While it is not directly related to the monitoring and maintenance, but again, it is something interesting I thought I'll just share. So somebody had made a study that people who in the US specifically, people who study, who go to college, who graduate, the probability of them being poor is very less. So college education versus economic prosperity is having a very high correlation, is something that guy was trying to tell about it, which seems pretty obvious. All right, college education and the prosperity, or seems to be pretty obvious. Somebody had debunked that particular, which nobody would argue on this, but there was another person who was arguing that we go one step back. College education versus existing economic index has a much higher correlation. Most of the people in the US have college education, graduate level college education, because they are already financially affluent. The poor people, it is very difficult. They have only less than 1% scholarship for poor students, and everything else is pretty expensive. So the fact that having a college education and not being poor is an absurd relationship altogether. All right. So I thought I'll just again, very, very commonly and well understood and well agreed upon statistic, college education versus economic index, has been totally debunked. All right. So that is why we need to probably, sometimes even reinvent the wheel and try to question everything before we can actually come to the conclusion. Thank you so much there. And also, sorry for the slight detour that I've taken. So yeah, Sharath, back to you. We were discussing about, hardware, server capacities, etc. You had mentioned. So my question to you is there some kind of a requirement that you are going to demand of your customers with reference to the hardware, or do you work with their existing setup and try to fit in? How does it really work? How do you choose the hardware requirements?
Well, Nitin, yeah, this is another very important aspect which the data science community probably does not get directly involved. But if you are uh, uh, dealing with data science projects or data related projects, as a project manager or as a manager who's trying to take care of these projects, you would probably look into these requirements very carefully. And you are going to draft. It is always, very straightforward. Correlation is there, which basically talks about what is the volume of the data that you are going to process and what is the hardware right standards that you are maintaining. And it also adds, if your data is too complex and if you have to rerun the algorithm multiple times, multiple iterations. So all these things are ultimately depending on the hardware, the computers, the servers capacity. So you should not undermine this particular important aspect. Now, you're not an expert. As a data scientist, you should probably be focusing more on the business aspects of the things, machine learning aspects, trying to solve the business problems and all that. But as a manager, especially if you are in that role, you would definitely try to consult your operations team, your hardware servers team, and all that, and then try to do a benchmark. So before we actually jump into um, doing the requirements gathering and say, hey, these are the requirements that we need, we do benchmarking. So we take small data set, sample data set from the client or whatever the data that we have received, right? So we quickly check, and it's again an ongoing process. And one of the important aspect is that scalability is also to be considered, because as I said, um, today's requirement might be for 1 GB data processing. Tomorrow, if the business grows, you will have to probably deal with 1 TB of data. Is your hardware capable to support that? This is one of the important question which is being addressed by cloud services. And this is also one of the reasons why the world is inclining towards the cloud platforms. And again, as I said, there are no standards as such that we'll have to use for hardware selection, but it is always an ongoing process, and we keep ensuring that the services don't go below the performance thresholds. And yeah, uh, you may not always get the required hardware, because there will be obligations with respect to the budgetary constraints could be there, the legal constraints could be there, data security constraints could be there. For example, when we were working on one of the projects with respect to Malaysia client, we did try to have the cloud as one of the cloud platform, but we couldn't, because of the data clauses, data security clauses. We couldn't use the cloud platform. We couldn't upload the data. The client was very adamant on not using a specific cloud that we suggested because of these rules, right? And so, as I said, hardware is something that you'll have to always negotiate and try to get good hardware resources so that your training also is smooth, and after training, your deployment also and your client also is looking at the performance of the model, and they don't get that slow I mean, I should say that the performance of the model should be in such a way that the negative impact should not be created there, right? So it's ultimately a service that we are giving.
Yeah, thank you. On that note, just to add what Sharath has spoken, the GDPR requirements, especially in Europe, suddenly they had started this requirement that their data cannot reside anywhere apart from their own countries or inside the European Union. And many people, in fact, big companies, I don't want to name now, very big companies that we had discussed, whom we know as our top companies, were suddenly at a loss. How do they work? They said, you send your team here to work on us. We will not let you access our data from our servers all the way to India, to Bangalore, to Cochin, etc. So it can happen. These kind of surprises also can happen, and you should be ready for those things as well. So monitoring and maintenance, like I said, is another big air pocket in the journey, the flight journey of the data science. We have to be, if you clear that, Okay, you can never say that, it is over, because you never know. It is going to be, needs to keep moving on. It's not a journey that stops and you reach your destination. It's an ongoing journey. So on that note, we need to stop here for the monitoring and maintenance, and we will discuss a lot more on these things. And like we discussed, like we informed you, starting next week, we'll be going deep dive into various ML topics, into the depths of it. We will try to dissect it, maybe not just at the organ level, but even to the cell level. We'll try to dissect it, keep dissecting it, so that everybody gets a clear picture on that. Thank you so much.
Thank you all, friends. Bye.